Hello everyone. Again, this is your junior high school math teacher, and I'm going to discuss about parallelogram and its properties. After you watch the video, you should be able to demonstrate understanding of the key concepts of parallelogram. Use properties to find measures of angles, sides, and other quantities involving parallelograms. And you should be able to participate actively during the discussion. Now in this material, you would be able to use properties to find the measures of angles, sides, and other quantities involving parallelograms. Now let us start with the quadrilateral itself, the parallelogram. Okay, so it is a four-sided figure, so what is this quadrilateral? Okay, so I put some arrowhead markings on each of these sides, indicating that this quadrilateral is a parallelogram. And let us name this as quadrilateral QUAD. Okay? And based on the arrowhead markings on each pair of opposite sides, QUID is a parallelogram. Since, okay, now each pair of opposite sides that are said to be parallel are known as the bases. Now, segment QU is parallel to segment DA, and these are the opposite sides, segment QU, segment DA, and they are also known as bases since these sides are parallel to one another. And similarly, we have another pair of bases since the two opposite sides, not the first pair, are also parallel to one another. So they are also the bases, base 1, base 2 of this second pair of opposite sides. Okay, so they are also parallel. Okay, segment DQ is parallel to segment AU. Now each pair of opposite sides from this parallelogram, from this quadrilateral, are parallel, which makes this quadrilateral a parallelogram. Now for the opposite sides, we have two pairs, so that is segment QU and segment DI, and they are the parallel sides. Similarly, we have segment DQ and segment AU, this one. So these are the two pairs of opposite sides, and each pair of sides are parallel to one another. Now what about the adjacent sides or the consecutive sides? So we have segment QU and segment AU. Now it's obvious that these two sides are adjacent because they have a common endpoint or common vertex, and that is point U. Likewise, for the second pair of adjacent sides, we have segment DA and segment AU. Where is it? Segment DA and segment AU. So obviously, their common endpoint is at point A. Now, for the third pair of adjacent sides, we have segment DA and segment DQ. And their common endpoint is point D. And finally, the fourth pair of adjacent sides, we have segment DQ and segment QU. This one. Segment DQ, segment QU. And obviously, their common endpoint is at point Q. Okay? Next. Now, we refer to the same quadrilateral, but this time let us talk about its angles. Okay. The same quadrilateral, we only remove some details from this quadrilateral in order for us to discuss the uh, about the angles, okay, or the next sets of pairs of angles. Okay, so we have the opposite angle, so that is angle Q together with angle A. Okay, and then similarly we have another pair of opposite angles, and these are angle D, this one, and angle U. Now for the consecutive angles, we have angle Q and angle U. So pag sinabing consecutive, magkasunod. Okay, walang lalampasan. Okay. Next, angle A and angle U. Yeah, this one, angle A and angle U. Next, we have angle D and angle A. This one, angle D and angle A. And the last pair of consecutive angles is angle D and angle Q. This one. Okay. Next, how about diagonals? So, pag sinabi nating diagonals, these are segments connecting two non-consecutive vertices of a polygon, particularly non-consecutive vertices of this quadrilateral, the parallelogram. And what are these diagonals? We have segment QA, this one, and segment DU, okay? Segment DU. So these are the diagonals, the orange line segments, okay? Next. So we go back to the definition of a parallelogram. It is a quadrilateral with two pairs of parallel sides. And let us now consider the following theorems on parallelograms. These theorems are actually properties of such quadrilateral. Okay? And what are these theorems or properties? First one is, opposite sides of a parallelogram are congruent. Second, opposite angles of a parallelogram are congruent. Third, consecutive angles of a parallelogram are supplementary. Now, if you are familiar with the last topic that I discussed, which is about the conditions that guarantee that a quadrilateral is a parallelogram, most of those statements, which are conditions, are also found so far in these theorems. Okay, so far I have the third property. Okay, then we go to the fourth. Diagonals of a parallelogram bisect each other. Then fifth, either of the two diagonals of a parallelogram forms two congruent triangles. So these are the theorems or properties of parallelograms. Okay. Next. Now, for you to understand these properties, let us apply them in some illustrative examples. Take, for example, in number 1, if quadrilateral ABCD is a parallelogram, find the measures of all the angles. Okay, so let us draw the given quadrilateral, this one. Now, we have two labeled angular measure which are both in terms of x, and they are leveled on a pair of opposite angles. And we know that in a parallelogram, the opposite angles are equal. Therefore, okay, so this is quadrilateral ABCD. So since angle A and angle C are opposite angles, then they are congruent, which is one of the properties or theorems related to parallelogram. So setting up the equation, angle A equals angle C, and we substitute their equivalent. So we have 3x minus 15 is equal to 2x plus 10. So we have just derived a linear equation in one variable. So solving for x, we just isolate those x terms on the left and those constant terms on the right. And we found out that the value of x is 25. Okay? And from here, we can now determine the measure of each of these of the four angles from this quadrilateral. Now since, okay, angle A, to find the measure of angle A, we take note of the expression 3x minus 15 and plug in the value of x, which is the obtained 25, okay? And simplify the resulting expression. We found out that angle A is 60 degrees. And for angle C, we know that is equal to angle A, so angle C is also 60 degrees. And for the other two angles, such as angle B and angle D, we use another property which relates to the angles of a parallelogram, and these are the consecutive angles. And we know that in a parallelogram, we've just known that in a parallelogram, consecutive angles or any consecutive angles are supplementary. Therefore, if our A is 60 degrees, it follows that angle B is what? 120 degrees. So we just need to subtract the obtained value of angle A from 180, and it will give us the measure of angle B, which is 120 degrees. And we know that angle B and angle D are also opposite angles, and in a parallelogram, opposite angles are congruent or equal in measure. So angle D is also 120 degrees. And at this point, we have just determined the measures of all the angles of quadrilateral ABCD, which happens to be a parallelogram. Okay? So again, angle A is 60 degrees, angle C is 60 degrees, angle B is 120 degrees, as well as angle D, which is 120 degrees. Okay? Next. Number 2. If quadrilateral ABCD is a parallelogram, segment AB is 2x plus 15 and segment DC is 3x minus 11, find x, the length of segments AB and DC. Solution. Now, these two segments are actually opposite sides since they don't have any endpoint in common. Okay? And in a parallelogram, they are equal in length. So AB is equal to DC. Okay? Opposite sides of a parallelogram are congruent. Next. Then we replace the equivalent length of each of these two. So for AB, that is 2x plus 15, and D is 3x minus 11. So at this point, we have just formed a linear equation in one variable, which is x. So solving for x, this will give us 26. Okay? Which is the answer. Okay? This one. Then for segment AB, we just consider the expression 2x plus 15 and plug in the value of x, which is 26, and simplify the resulting expression. We found out that the length of segment AB is 67. And for DC, okay, now for DC, we consider 3x minus 11 and substitute x by its equivalent value, which is 26, and simplify the resulting expression. You will notice that the value is the same as the value of segment AB, which is 67. So therefore, the length of segment DC is also 67 or 67 units. And these are the answers. Okay? Next. Okay, I'm not going to discuss this one. No? You just look at the given and what is to be proven, and together with the formal proof. Okay, okay, we go to the next slide. Okay, I'll give you 5 to 10 minutes to work on this activity number 1. Okay, use the figure on the right, the parallelogram DEFG, to complete each of the following statements from 1 to 10 and give your reason to justify your answer. Okay? Okay, so let us now reveal the answer. I think everyone is done answering the seat work. Here goes. Okay, segment EF is congruent to what segment? Segment DG and Y. Opposite sides of a parallelogram are congruent. Next, angle E is congruent to angle G, Y. Opposite angles of a parallelogram are congruent. Next, segment FG is what? Congruent to segment ED. Why? Again, opposite sides of a parallelogram are congruent. Next, number 4, segment EH is congruent to what? Segment GH. Why? The diagonals of a parallelogram bisect each other. Okay. Next, number 5, angle D is congruent to angle F. Why? Opposite angles are congruent, or opposite angles of a parallelogram are congruent. Number 6, segment DH is congruent to segment FH. Why? Diagonals of a parallelogram bisect each other. 7, angle DEF is congruent to triangle. Okay, triangle DEF, is congruent to triangle FGD. And why? Either of the two diagonals of a parallelogram forms two congruent triangles. Number 8, angle E, or the measure of angle E and that of angle F are what? Supplementary. Why? Consecutive angles of a parallelogram are supplementary. Okay. Number 9, angle D plus angle G are what? Is equal to what? 180 degrees. What is the reason? I think the same reason stated in number 8. Consecutive angles of a parallelogram are supplementary. And the last one, angle EFG, or triangle EFG, is congruent to what? Triangle GDE. And why? Either of the two diagonals of a parallelogram forms two congruent triangles. Okay, and at this point, I have just finished discussing this topic. And I'll see you next time.